So today we are going to start multiplying our radicals, the next operation. And we have just a general rule for multiplication, which applies to all cases, is that we're going to multiply things outside of the root with other things that are outside the root. So we keep the similar parts and multiply those. And we also multiply things under the root with other things under the root. And that's really going to happen in every possible case, but there are a variety of different multiplications that we can see. So let's look at our first example. Here we have the square root of 6 over the square root of 20. For our key points, the first thing we're going to do is simplify all radicals. And this might not be necessary all the time, but if possible, simplify your radicals. So for 6, I break it apart and I see I get 2 and 3. So there's nothing I can pull out, so that is already simplified. For 20, I know it's 4 times 5. 5 is prime, and then 4 can break down to 2 times 2, which is prime. So I can simplify this further. So I have the square root of 6 times, I bring out a pair of 2's, the square root of 5. Once I have simplified, my next step is to follow my multiplication rule. All right, multiply. And I want to multiply the numbers outside with the numbers inside. So my number outside, we have this imaginary 1. So really I'm going to multiply 1 with 2, because both of them are out in front of my radical. And then you're going to multiply 6 with 5, because both of those are under the radical. So 1 times 2 is 2. I keep my radical. 6 times 5 is 30. So that is the key to multiplication. And then number 3 of my key points is to double check once you've multiplied if you can simplify again. So check to simplify again. So can I break down 30? Well, I know that it's 3 times 10 and 2 times 5. And even though I have multiple factors, none of them are pairs. So 2 root 30 is my most simplified product. Let's look at another example. Something like number 2. I have negative 5, the square root of 15, times negative 3, the square root of 6. I want to double check if I can simplify 5 times 3. No, I can't. 15 is as simplified as it gets. So I just follow my rule. Multiply the outside with the outside and the inside with the inside. So outside I have negative 15 times negative 3. Inside I have 15 times positive 6. Negative 5 times negative 3 is negative 15. And then I could push this together, which would give me 90, so positive 15 root 90, but then I would just have to break it up again. So I'm just going to understand that both of these things are multiplied underneath, but rather than factoring 90, I'm just going to break 15 up and say, well, I know that this is 5 times 3, and this is 2 times 3, and now I have all my factors, which is the exact same thing I would get if I did 9 times 10. Here I have 3 and 3, and 2 and 5. It's just saving me the step of pushing it together just to break it apart again. So here I do have a pair of 3's, which are going to come out. And inside my radical, I still have a 5 and a 2. And so negative 15 times 3, this is a negative times a negative is a positive. So then I have 15 times 3, which is 45, and the square root of 10. And 10 can't break down, so there is my simplified product. These rules still apply when I have third roots, fourth roots, or higher roots and indexes. So again, I want to multiply the numbers outside. So I have 3 times negative 3 outside, and multiply the numbers that are inside. And again, I have a third root, so I really want to make sure that I'm not forgetting my index. And then I have 3 times negative 2. 3 times negative 3 is negative 9. The third root of 3 times negative 2 is negative 6. And because it is an odd root, it's okay for us to have a negative inside, and that is our simplified product. So far we've only been multiplying a monomial times a monomial, and sometimes they had coefficients, sometimes they didn't. So let's see you try one on your own. Here we have negative square root of 20 times 3 the square root of 15. Go ahead, follow the key points, double check your work, and we'll come back in a second with the answer. So you should have gotten negative 30 root 3. I would have recommended simplifying the 20 first, then multiplying the outside. Technically this negative is like a negative 1, so make sure you don't lose the negative. Multiply the outside, multiply the inside, and you should have gotten negative 30 root 3. If you didn't, double check your work and come ready with questions. Moving on, now we have a monomial, or one term, times 2 terms involving radicals. So just as we would in a regular problem with a monomial times a binomial, I'm going to distribute my 6 to both terms. Since 6 is technically a number outside of a radical, we'll treat it as such when we get to the radical. So this is going to become 6 times negative 3 for this first rainbow distribution, plus 6 times 5 root 2. So again, 6 times negative 3 is just regular multiplication. We multiply to get negative 18. I add, and here I have my rules that I need to remember for my radicals. So I'm going to multiply the numbers outside. So 6 is outside, so 6 times 5 is 30. And I don't have anything inside except for the root 2, so I'll just leave root 2. These are not like terms because they don't have similar radical parts. So that is my product, and that's as simple as it gets for radical distribution. Okay, so another example where we are distributing a radical to a binomial, which is 2 terms, is going to be very similar. It's just like regular distribution, but it's slightly different because now we're distributing a radical. So here we have our 2 rainbows, and again I want to multiply the square root of 3 times the square root of 6 plus the square root of 3 times 2. So here there's nothing in front of our radicals, so really it's just 1 times 1. But inside we have a 3 and a 6, so inside I have 3 times 6, which is 18. Plus, here I have nothing in front but a 1, and 2 is technically outside of the radical, so 2 times 1 is 2. And 3 is the only thing inside, so we leave it as 3. And now we need to continually be checking, do we have our answer in simplest radical form? So 3 is, because I can't break that down, that I need to check for 18, which is 9 times 2. And 9 is 3 and 3. So I can simplify this even further. So I pull out my pair of 3's, radical 2, plus 2 radical 3. And because they are not similar radical parts, they're not like terms, so I can't be combining those. So our final product is the 2-term answer that we have here. Let's try one more example, getting a little more difficult. Now we have a binomial times a binomial. The rules still apply. This is a case where we want to use our box method. So I have 2 to the square root of 5 minus 4, and the square root of 2 and positive 7. So create your box, and this is going to help you with your multiplication. If you need to write it out first, 2 to the square root of 5 times the square root of 2, to help you with your multiplication, do so. Don't take shortcuts, you will make mistakes. 2 in front times 1 is going to be 2, and inside 5 times 2 is 10, so we're going to have radical 10. Then I have negative 4 times radical 2. Negative 4 is outside. Radical 2 is inside, so it just stays that way. Here I have 2 radical 5 times negative 7. 2 times negative 7, which are both outside, is negative 14. And radical in 5 just stays by itself. And here we have negative 7 times negative 4, just regular old multiplication, gives us a positive 28. So we rewrite all our terms. 2 radical 10 minus 4 radical 2 minus 14 radical 5 plus 28. Again, our binomial times a binomial is the best time to use our box method. Once we get this, we always need to be double checking. Are they simplified? And it really doesn't hurt to just test it out. 5 times 2. Oh, okay, I know it is. 2 is. 5 is. So I know that they're simplified. Once I double check that everything is simplified, I need to check for like terms. I do not have any similar radical parts, so this large answer is my product. That's as simple as it can get for this particular problem. One last example is another version of a binomial times a binomial. We have to remember, right, a quick tip, a common error is that you cannot distribute that little exponent 2. That's not how this works. This is a box method problem. Alright, so we need to rewrite this as 5 the square root of 3 plus 2 times 5 the square root of 3 plus 2. These are two groups being multiplied, and again, this is a box method, so we write 5 the square root of 3 plus 2, and then along our side, we have 5 the square root of 3 and 2. And here we have our boxes. So again, if it needs to be written out first so that you're not making mistakes, inside we have the square root of 3 times, outside 5 times 5 is 25, and inside 3 times 3 is 9. Outside is 2 times 5 is 10, and I'll rewrite this. 5 the square root of 3 times 2, so 5 times 2 is 10, square root of 3 is inside. We have 5 the square root of 3 times 2, so 5 times 2 is 10, square root of 3. And here we have just regular multiplication. 2 times 2 is 4. So we rewrite it from all of our terms in the boxes. 25, the square root of 9, plus 10 the square root of 3, plus 10 the square root of 3, plus 4. The first thing we need to do is check, can we simplify our roots? And yes, 9 is a perfect root, so if I simplify that, I just get 25 times 3. We also see that we have like root parts, so we can combine this. 10 the square root of 3, 10 the square root of 3. We combine our coefficients to get 20 the square root of 3, and my 4 tags along. 25 times 3 is 75, so 20 the square root of 3 plus 4. And now again I have like terms, so I can combine 75 plus 4 to be 79 plus 20 the square root of 3. So this is definitely the trickiest example of all of these types of problems, because you have to remember not to distribute. We're doing a box method here. Then we get these groups where we can combine like terms. We also have roots that we can simplify, and then again we have like terms to simplify. So there's a lot of extra stuff going on after we do the multiplication. So here we have a few problems for you to check yourself with. We have a monomial times a monomial, a distribution type problem, and one of the harder multiplication problems. So please try all of these problems in your notes and come ready to discuss them after the Do Now tomorrow.